This video is for Chemistry in the Earth System, Unit 3.1, Ion Formation. Today's essential question is, how do monatomic ions form? Our first main idea, monatomic ions. Atoms are the smallest units of an element. A neutral atom does not possess a net charge because it contains an equal number of positive protons and negative electrons. For example, an atom of sodium, like the one shown on the screen here, contains 11 protons in its nucleus and 11 electrons outside its nucleus. The charges on a proton and an electron are equal in magnitude. So, the negative charges of the 11 electrons outside the nucleus balance the positive charges of the 11 protons inside the nucleus. This balance makes the atom neutral. A neutral atom acquires a charge if its positive and negative charges become unbalanced. This happens when an atom gains or loses one or more electrons. The atom then becomes a charged particle called an ion. For example, when an atom of sodium loses one electron, it still contains 11 protons, but now only 10 electrons. Since the sodium atom now has one more positive charge than negative charges, it has a net charge of +1. The symbol for this ion is written as Na1+, or Na plus for shorthand. Many ions consist of a single charged atom. For example, an ion of sodium is one charged sodium atom. An ion that consists of only one charged atom, like the sodium we just discussed, is what is known as a monatomic ion. The chart on the screen here shows some examples of monatomic ions. Each ion's charge is either positive, represented by a plus sign, or negative, represented by a negative sign, and has a value somewhere between 1 and 4. A value of 1 is represented by a superscript plus or minus sign, meaning you don't actually draw the 1. Values greater than 1 are shown by placing a number in front of the plus sign or minus sign. For example, the sodium, or should I say rather, the calcium ion has a charge of 2 plus. Therefore, it is written as Ca2 plus. But in contrast to monatomic ions, polyatomic ions form when a group of atoms are joined together and have an overall positive or negative charge. For example, the hydroxide ion, which is OH minus, contains an atom of oxygen and an atom of hydrogen. There is one more electron than proton in this group, so this polyatomic ion has a charge of -1. Polyatomic ions will be discussed in more detail in another concept. Transfer of electrons. Monatomic ions form when single atoms gain or lose electrons. In general, this happens when one or more electrons are transferred from an atom of one element to an atom of another element. The atom that loses one or more electrons becomes positively charged. The atom that gains the electrons becomes negatively charged. For example, common table salt is a solid compound made up of one atom of sodium and one atom of chlorine. The formula NaCl represents this compound. However, to form this compound, each sodium atom transfers one electron to each chlorine atom. So, a more accurate representation of table salt could be Na plus Cl minus.
Ionic crystals are a special kind of crystal. They're the only type that contain ions. Ions are atoms that have lost or gained electrons to become charged. Positively charged ions are called cations and come from a metal. Negatively charged ions are called anions and come from a non-metal. To understand them better, let's take an example of a common ionic crystal, ordinary table salt, sodium chloride. This is made of metal sodium cations and non-metal chloride anions. The ions attract each other and are held together in a regular lattice pattern, with the oppositely charged ions next to each other. They're bonded by strong electrostatic forces. But not all ionic crystals follow this same pattern. Titanium dioxide is found in most sunscreens because it blocks UV rays. Its structure looks like this. The metal titanium is the cation, while the non-metal oxygen is the anion, and the crystals form a different shape. Ionic crystals do not conduct electricity when they're solid. This is because the ions are fixed in place. But if the crystals are dissolved in water, the ions are free to move and can carry an electric current.
At this point, you should be able to generate a full and appropriate response to today's essential question. How do monatomic ions form?